Characteristics of acids and bases. Characteristics of acids and bases. Functional characteristics. Again, functional is how something acts or reacts. These are true, some you don't want to do. Acids tend to react with metals. They have a sour taste. I don't think you would want to taste an acid in particular. Bases feel slippery to the touch. Again, you probably don't want to touch a base if you don't know what it is or how strong it is. Bases taste bitter. So these are functional definitions on what to do. There's solutions in general. Acid and base is in specific deal with strength. The strength of a solution. The strength of an acid solution, the strength of a basic solution, depends upon what percent of the molecules fall apart. Representation of two solutions. They both have the same number of particles. Maybe H plus and Cl minus or something like that. So there you have three molecules and only one of them has fallen apart. Here you have the same number, 1, 2, 3, 4, 1, 2, 3, 4, same number of particles, but 100% has fallen apart. So this is only 25% has fallen apart. So this is a stronger solution. It's a stronger acid solution, stronger basic solution. It was hydroxide. This is a weaker solution. So strength deals with percent of molecules that fall apart. Concentration is different. Concentration of a solution is what numbers are present. Again, we have our two solutions. Try to make it look like it's equal volume. Here we have one molecule, and here we have more than one molecule. This is more concentrated. This is a concentrated solution because it has more particles. This is a dilute solution because it has very few particles. You can have a strong dilute solution. You can have a weak dilute solution. This is an example of a weak dilute solution right here because there's that. If there were more particles falling apart, this would be maybe, now let's cross that off. Let's say we have this situation. That would be an example of a dilute strong solution. All the particles fall apart, but there's not very many particles there. So you can have four combinations. You can have a weak dilute solution. You can have a weak concentrated solution. You can have a strong dilute solution. You can have a strong concentrated solution. It just deals with how many particles there are and what percent falls apart. pH scale, 7 is neutral. And for our purposes, anything that rounds to 7, so 7.4, 6.5, we'll call that neutral. Anything greater than 7 up to 14, you can have 15 actually, but generally you don't, is a base. Anything 1, actually you can go down to 0, is an acid. So acids have pH less than 7, bases have pH stronger than 7, and for our purposes, anywhere between 6.5 and 7.4, anything that rounds to 7 is neutral. So that's the pH scale. The smaller the number, the stronger the acid solution is, the more acidic it is. Again, this deals with strength and concentration both. If you have a number higher, if you have 12, 13, 14, that's a pretty strong base, or concentrated base, as the case may be. There are, to measure the pH, this is the pH scale. To measure the pH, you can use an indicator, which is a liquid solution that you put a drop in. So you put a drop in the solution, take a sample of your stuff and put a drop in the solution, and depending upon if it's a universal or specific, indicators sometimes would change color at a specific pH. What they are weak acids, and they change color. So you can have a universal solution, which means you put a drop in and you kind of check the color according to a key, or it can change color at such and such pH, like 5 or 10 or something like that. So you got an indicator, which is a liquid. You can have a solid pH paper or litmus paper. pH paper is a universal indicator soaked onto a paper. And again, you got to have a color code. It's a color key. What color the paper turns instead of the whole solution tells you what the pH is approximately. Litmus is more general. Red gives you an acid. It's actually pink, but that's close enough. So the way you remember it, red, acid, and then base is blue. Base blue, red acid. So that's how you can tell the difference with litmus paper. Litmus paper, and you need both of them, because if they both turn red, it's acid. If they both turn blue, it's base. If neither changes, red stays red, blue stays blue, then it's neutral. And no, you can't have the red turn blue and the blue turn red. Can't do it. And the most accurate, high-tech, most expensive way is to use a pH meter. pH meter depends upon how much electricity passes through the solution, and it registers what the pH is. Usually digital. pH meters are more expensive. They cost some money, but they are generally really quick to use. You can also use pH meters if it's a colored solution. If you're doing like colas or coffee, you can do a pH paper or pH meter readily. You probably can't tell with, say, a cola or coffee using a pH indicator, a liquid indicator, because the solution is so colored that you can't see what the color changes. So that ends this lesson on characteristics of acids and bases.